Hi everyone, my name is Chelsea and I'm going to be going over a few of the problems that we learned about in Module 2 here. So number 1 says to let U equal A through H. A is going to equal the letters B, C, D, G, and H. B is D, F, and H, and C will equal D, G, and H. So that just basically means that those letters are included in that circle. So it tells us here to create a 3-loop Venn diagram to show all 8 elements of U. Then list the elements in the following sets. So what I did here is I just went ahead and listed everything that is included in that set. So this upward U symbol stands for OR. So anytime we see a U, an upwards U, it's going to mean anything that's in B or C. And then the downward symbol is AND. So anything that is in A and B, and so on. E is a little bit differently here. We have an A with the little line above it. That just simply means that you will select everything else that is not a part of A. So what you'll do is you'll look here back at your stuff here and you will list everything that is in B and C as long as it is not a part of A. So what I did is I created my Venn diagram here for you. You see A, B, and C. Each circle has a letter representing it, A, B, and C. And then what I did here is I just put everything that belonged in A by itself that was in nothing but A. Same for B and same for C. And then what you see here is anything included that's in A and B. Anything in this section is anything in A and C. And this one is anything in B and C. This little section here in the middle is anything that will be in A, B, and C. So that's where I did. I just plugged those letters into the in the position where it would be where it would fit. So the 2 letters you see here, A and E, they are a part of the universe, which was up here that says all of the letters of A through H. And those 2 letters, A and E, were not listed in A, B, or C, but they were in the universe. So we would keep them within that square that we call the universe, but not in the circles. Next, we're going to look at number 2. We have another Venn diagram, and there are 12 shapes inside of it. We see hexagons, we see triangles, and we see circles. And we have some smaller hexagons, and we also have smaller triangles. So what it says here is that C, H, and T are going to denote circular, hexagonal, and triangular shapes. S, L, and R are going to be small, large, red and blue. I left out my B, I'm sorry. So S, L, B, and R are going to be small, large, red, and blue. So as stated in the above problem that we did, the upside down U stands for and the upwards U stands for OR. So the L is going to represent large and the H hexagonal. So we have large and hexagonal. And then the same with this one. C represents circles, H represents hexagonal, so it's circle or hexagons. C is a little bit differently. We see the R with the line above it. Again, that just means anything that you see in your universe, your set there, that is not an R. So R stands for red, so it's going to be anything that's triangular and not red. So if it's a triangle and it's not red, we will list it. Same thing for D. We'll do the same exact there. Number 3 here says to write the Indo-Arabic equivalent of each of the following. So you'll see that I made you a little key here at the bottom. The pointing fingers is equal to 10 to the 4th power, or 10,000. The yoke is equal to 10 to the 1st power, or 10. And the staff is 10 to the 0 power, or 1. So we have 3 pointing fingers, which is 30,000. 5 yokes, which stands for 50. And then 4 staffs, which is 4. So our answer is 30,054. B is going to be Roman numerals. Here we have letters to represent numbers. So the M is going to equal to 1,000 here. And then right here where you see the C listed before the M, that C is 100, and then you have 1,000. You can't do 1,000 plus 100 plus 1,000, because then it would be the incorrect answer. So the way you have to do it with the Roman numerals, because if you have a smaller number listed in front of a larger number, you're going to deduct that. So you would subtract 100 from 1,000. So you get 1,900, and then the x's are 10, so that's going to be 35, 36, 37. 1,937. C, it's very simple. You're going to see 3 sideways triangles here at the front and 1 downward facing triangle. So it's going to equal 41. If you look at the key, the sideways triangle is 10 and the downward is 1. So it's going to be 41. In D here, I'm going to read you what I wrote here at the bottom first because that is very important information. You have 4 digits listed here in your problem. So you're going to start with the first value, which is 5, and multiply it by this formula I listed here. And I listed the formula for each of your numbers so that way you know how to multiply it. So we have a line here which is equal to 5, a line with a dot which is equal to 6, 3 dots which is equal to 3, and 3 lines and 2 dots which is equal to 17. So here you see where I multiplied 5 times 18 times 20 squared, which is 36. Once you complete all 4 of those formulas, you're just simply going to add your answers that you got in the formulas, and that will be your answer. So the answer for part D is 38,237. Number 4, it looks very intimidating, but I promise it is so simple. So it's just telling you to use lattice multiplication to solve parts A through D. So the first one says to multiply 28 by 32. What you simply do is you just create a 2 by 2 square, and you're going to put the 28 above it and then 32 on the side. I put a little multiplication symbol to make it a little bit easier to remember. And what you do, inside of each square, you create a diagonal line. So you're going to multiply 8 times 3, and your answer will go here in the center. It's going to be 2 on top and 4 on the bottom for 24. And then you're going to multiply 3 times 2. You'll write your answer in this square, 0 and 6. And then you'll do the same thing for 8 times 2 and 2 times 2. Once you're finished multiplying those, you're going to start here at the bottom, and you're going to go work your way up through each diagonal, and you're going to add those. So it'd be 6 here at the end, 4 plus 4 plus 1, which is 9, and then 6 plus 2 is 8. And I did make a mistake here, and I'm so sorry. I just switched my 9 and my 6. The answer is actually 896. So you're going to do the same thing on all the rest of them, except for this one you'll have a 3 by 3, so you'll do 3 by 3 on the squares. And you'll work it the exact same way to come up with the 17,444. Same thing for C. It's going to be 3 by 3, and you'll work it the exact same way. And on D, it's a little differently because you're going to be doing a 4-digit number by a 3-digit. You'll set it up the exact same way. Your first number goes on top here, so you'll have 4 squares on the top, and then you'll have 3 going down. You work it the exact same way. Multiply your 2 by all your digits on top, then your 4 by all the digits on top, and your 3 by all the digits on top. You will go back through and you will add each diagonal, and that is how you come up with your answer. So the answer on D is 1,203,336. Told you it is not hard at all, I promise. It looks kind of intimidating because there's so many numbers within that square, but it's super simple. And on number 5, it asked us to use rounding to the leftmost digit to estimate the results of each of the following. So what I did here is I took my top number and I just added it here, so we'll know what that is, and that's what's going to go on the inside of our division problem here. And you just work that out like a regular division problem, and you're going to divide. So we have 10 here, 0.05. So we're just going to round, and that 0.05 will go up to 10.01. Your 5 here will round that 0 up to a 1. So any number 5 or larger will make your digit to the left of it round up. If it's 4 or below, then you will keep that digit the same. So if it was 10.04, it would stay 10.0 or 10. So because it's 5, we round up, it's 10.0. It's the same thing for all of them. What you do is you just kind of solve this here first. So you're going to do your 5 times 254 and then add the 523 to that. And that's going to go in your division problem here on the bottom, on the inside, and you add the 35 plus 7. Work it the same way. The 6 here, it's larger than 5, so it's telling our 42 to round up to 43. And then the same thing on C. It's a little different because you're just multiplying the top. But once you solve that, you'll just plug that in here in your division problem and work it the exact same way. Your 909.7 is going to round that up to 910. And then our very last problem here, it says to perform the following operations in the relative base. This one is just like normal addition, but it is worked a little bit differently because we're using base 5 and base 6 instead of our normal base 10 that we are used to. So with base 5, anything above a 5, or if it's 5 or above, you cannot write it here on the bottom. So we have 3 plus 2, which is 5. So because it isn't below 5, we can't write it here on the bottom. So what we'll do is we're going to ask ourselves, how many times will 5 come out of 5? It'll only come out once with no leftovers. So you'll put your 1 here on top, just like you would normally carry over your 1. And then your 0 would go here for how many you have left over. Same thing as you move through the problem. 3 plus 3 plus the 1 we carried over is going to be 7. 5 will come out of 7 one time with 2 left over. So we carry our 1 up here for the 1 time we pulled our 5 out, and we bring down our 2 that was left over. And that's how we work through those problems. So our answer for that one is 1,120 with a base of 5. And it's the same way for B, except we're working with a base of 6 instead of 5. So it can be 5 or lower for it to be able to stay there. If not, we have to kind of pull it out how we did the last operation. So you have 8 plus 3, which is 11, and you can't put 11 here because it's higher than 5. So what you'll do is you'll ask yourself, how many times can you pull 6 out of 11, which is only 1. You'll carry that 1 time that you pulled that 6 out right here, put a 1. And the 5 is what you have left over. So it would be 6 plus 5 is the 11. And then you work it the same way as you did before, but with the base 6, obviously. And so our answer on this one is 1,145 with a base of 6. C and D are a little different just because you're subtracting. That's the only difference. You still work the problem the exact same way. So you're going to have 414 with a base of 5 minus 43 base of 5. So it's the same way. 4 minus 3 is 1. It is smaller than these numbers listed here, or it is within those numbers. So we can leave that on the bottom. 1 cannot be subtracted from 4, so you cannot do that. You'd have to borrow your 3 and make this here 5 because it's the base of 5. So we drop that down. 5 minus 4 is 1, and then the 3 minus the imaginary 0 here is going to be 3. So that is our answer, 311 with a base of 5. Same thing on part D here. We're going to do the exact same way. We're going to borrow, and that's how we come up with our answer. We're going to get 479 with a base of 5. Thank you guys so much for watching. I hope this helped you out with this module 2.